And we're going to talk about angles and segments. All right, for the first section here, we're interested in, I'm just going to start with a picture. We have lines or segments or something that intersect inside the circle but not at the center. So in that situation, we have something like this. We have two segments that are intersecting inside the circle. But they intersect not at the center. So these are not central angles. And I'm going to label a couple of things. I'm going to call this arc X, this arc Y, and this angle 1. So our vertex is inside the circle. In this case, there's a relationship between the angles, angle 1 and the arcs. The measure of angle 1 is x degrees plus y degrees divided by 2. And the way I think about this is the angle equals the arc plus the arc divided by 2. In your flip book, this picture is the second one on the page inside the cover. So in your flip book, what I would suggest that you write for this one is the vertex is inside the circle. And I'm just going to have you fill out the part about the angle because I think that's what makes the most sense. So in your flip book, you would say, I'm just going to put that over here as a little note. In your flip book, I would write the measure of angle AVC, which is already there, equals the measure of arc AC plus the measure of arc DB divided by 2. And you could put this little symbol if you want. The angle, when the vertex is inside the circle, not at the center, the angle is the arc plus the arc divided by 2. And the two arcs that we're talking about are the arcs that are intercepted on either side of the angle. Because these two angles are the same, the two vertical angles. All right, so that's our first rule for today. The second one, we have 3 possibilities here. So with that information, you should have the first 2 pages of your flip book full. So we have the central angle, we have the vertex inside the circle, but not at the center. We have the inscribed angle that we talked about yesterday, and the secant and the tangent. But both of those are where the vertex is on the circle. So now we can move to page 3 for our flip book. And we have 3 possibilities when the vertex is outside the circle. Everybody good here? So here we have lines or segments or rays or something that intersect outside the circle. So I'm going to say the vertex is outside the circle. And I'm going to draw 3 possibilities here. So we have this, this, and this. The first one, we could have what we call secant lines. So our situation could look like that. And I'm going to call this x degrees y degrees, and this angle 1. So we have two secants. Secants are just lines that cut all the way through the circle. We could have a secant and a tangent and have our vertex outside the circle. I'm going to call that x degrees, that arc, this arc y degrees, and this angle 1. So we have a secant plus a tangent. So that gives us a possibility for the vertex outside the circle. We could have two tangents. So I could have something like this. On all of those, the vertex, I'm going to call that x degrees, that big one. This one y degrees, and this angle 1. So we could have two tangents. All right, so our vertex is outside the circle. Not a central angle, not an inscribed angle. Angle 1 is none of those. The rule is the same for all of these. The measure of angle 1 is x degrees minus y degrees over 2. And the way I think about that is, for this situation, with the vertex outside the circle, the angle equals the arc minus the arc divided by 2. The big arc minus the small arc divided by 2. And the arcs that I'm talking about are the ones that are on either side of the angle here. All right, so in your flip book, you have, in your flip book, the two tangents are first, and then it does the secant and the two secants, and then the secant and the tangent. So what you want to write in your flip book for this one, for the two tangents, that or the two tangents is the first one on the top of the page there. The measure of angle AVC. So this is in our flip book. The measure of angle AVC equals the measure of arc AC minus the measure of arc, so I'm going to write this, that's a major arc, so I'm going to say AXC, minus the measure of arc AC divided by 2. For the next one down, for the two secants in your flip book, you want to write the measure of arc AVC, which it has there, is equal to the measure of arc BD minus the measure of arc AC divided by 2. So that's your two secants on the bottom of that page there. So that would be the first, second, the third page. And then finally, on the top of the fourth page, the secant and the tangent in your flip book. You want to write the measure of arc AVC, or sorry, angle AVC equals the measure of arc BC minus the measure of arc AC divided by 2. And on all of those, you might want to write, you don't have to write it for every single, you don't have to write it over and over, but you might want to give yourself a reminder that for those three, the vertex is outside the circle, and the little symbolic way to think of it is the angle is the arc minus the arc divided by 2. So that's how it works for all three of those cases where the vertex is outside the circle. Now when you do your quiz, when you do your test, you'll have a note sheet that has these rules on it for these arcs and angles and the inscribed angle and the central angle, all those things. So have a list of those rules. You just need to know how to use them. Kind of like for the Chapter 11 test. All right, questions there? So let's take a look at a couple of examples using these two cases, where the vertex is outside the circle and where the vertex is inside the circle. All right, here's our setup. This is going to look kind of like the opener. And if we had known this, this might have made the opener easier. But we didn't know this stuff yet. I'm going to say that angle, that arc is 87 degrees. That arc is 165 degrees. And this is x degrees. And we want to find x. We have our vertex inside the circle. The vertex is not at the center. So we know that in that case, that the angle equals the arc plus the arc divided by 2. That's our rule. So the angle, x, equals the arc, 87, plus the other arc, 165, divided by 2. Add those together, I get 252 divided by 2. And when I divide that by 2, I get 126. All right, questions there? All right, let's look at another one. This one will be one where we have our vertex outside the circle. And we're going to say this is 22 degrees. This is y degrees. And this is 98 degrees. And we want to find y. Well, here we know that our vertex is outside the circle. We have a secant and a tangent. Secant in Latin means to cut. So the secant cuts through the circle. We want to find y. We know our angle vertex is outside the circle. So we know that the angle is the arc minus the arc divided by 2. So we just plug in our information into this little formula, acronym formula. The angle, 22, is the big arc, 98, minus the little arc, y, divided by 2. And we just need to solve for y now. So what's going to be our first step? Multiply by 2. So I'm going to get rid of that 2 in the denominator, so I'm going to multiply everything by 2. Those cancel. So I get 44 equals 98 minus y. Now I could do a couple of different things here, a couple of different steps. I'm just going to subtract 98 from both sides. So 44 minus 98, need to be a little careful, is negative 54 equals negative y. Well, I can multiply by negative 1 or divide by negative 1, and we get y equals 54 degrees. All right, questions there? Okay, let's look at one that's a little trickier, but still the same idea. All right, so this one is about a satellite that's orbiting the Earth. So here's our little satellite. Those are its little antennas. And it's in orbit above the Earth. And we know that the angle formed by two tangents is 17.5 degrees. So if the satellite were above the Earth, this is how much of the Earth the satellite could see. It could see to the tangent points. And we want to know what is the arc of the Earth that can be seen. So it's asking for that arc. That's how much of the arc of the Earth the satellite can see if this angle is 17.5 degrees. We know that the vertex is outside the circle. So we know that the angle equals the arc minus the arc divided by 2 because the vertex is outside the circle. Well, one arc is x. The problem doesn't tell us anything about this arc. But can we figure out something about that arc? What's the arc all the way around the Earth? 360. So this part is x. What's left for this part? 360 minus x. So this arc is 360 minus x degrees. Now we can plug those in. The angle, 17.5, is the big arc, 360 minus x, minus the little arc, divided by 2. So 17.5, I can simplify this, 360 minus x, 360 minus 2x over 2 equals 17.5.
Just our copies or Melissa copies too?
No, Melissa has hers. I stole that from Melissa.
Okay, thank you.
All right, so we're going to do the same thing we did in the last one. Multiply both sides by 2. Those go away. 17.5 times 2 is 35. And that gives me 360 minus 2x. Those 2's go away. This is just like the last one. Subtract 360 from both sides. When I subtract 360, I get negative 325 equals negative 2x. Divide by negative 2. And x equals 162.5 degrees. This one is a good one to have written down in your notes because something very much like this does show up on your test. All right, questions? All right, now we're going to move from talking about angles to talking about segment lengths. And in your flip book, you'll notice that the next 3 circles that are in there have a gray background. That's how the flip book shows you that you're talking about lengths rather than angles. So in your flip book, the gray background has to do with lengths. So we have 3 possibilities here. We have the possibility where our segments intersect inside the circle. Like so. And for this one, this is the very last one that's in your flip book. So the very last one. I'm going to label these lengths A, B, C, and D. So here we have 2 chords. For this situation, A times B equals C times D. So this piece times this piece equals this piece times this piece. The way that I think of this is the part times the part equals the part times the part. And honestly, in your flip book, I would label those segments A, B, C, D like we just did here, and I would cross out what it has written there, and I would write what we wrote here. I think that was going to make more sense. So label the parts of one segment A and B, the parts of the other segment C and D, and write exactly this in your flip book. And that's on the very last grayed out circle in there. All right, so the second to the last, we're kind of going backwards in your flip book now. The second to the last grayed out circle, it looks like this one, where we have 2 secants. So our segments intersect outside like so. And I'm going to label the segments again. So I'm going to label this part that's outside the circle D, this part that's inside the circle C, this part B, and this part A. So I would label your little circle in your flip book just like this. I know that it's kind of small for the B and the D there. Now this whole segment is C plus D. And this whole segment is A plus B. I'm going to put up here, down here, we have 2 secants. The way it works for this situation is C plus D times D equals A plus B times B. And the way I think of this one is the whole times the outside equals the whole times the outside. So this whole segment, C plus D times D, equals this whole segment, A plus B times B. So that's our situation when we have 2 secants. All right, we'll go backwards one more. So I would cross out what's written next to this circle in your flip book and write just what we wrote here. All right, the third one, so going backwards one more. We have a secant and a tangent. So our drawing looks like this in your flip book. So we have a secant and tangent. And I'm going to label these things. So I'm going to label the outside portion of the tangent, this piece, C. The inside part here, A, and this part, B. This whole length, just like before, is A plus B. So what we're going to say for this is a plus b times b, so just like before, the whole times the outside, equals, well, we only have an outside piece here, equals c squared. And the way I think of this one is the whole times the outside equals the tangent squared. And we could think of this as the whole times the outside, but the whole and the outside are the same. So it's c times c. So this is the third to the last picture in your flip book. So I'd cross out what it has written in there, label the diagram just like this, and write what we have here. I think that's going to be a little easier to remember. And if you back up one more section in your flip book, there's one other gray circle in there where we have two tangents. And we talked about that one before. If we have two tangents that intersect outside the circle, the tangents are the same. So in your flip book, you'd write the measure of segment AV is congruent or is equal to the measure of segment VC. Those two segments are equal. So in your flip book, on which is the first gray one in your flip book after the non-gray ones, measure of AV equals a measure of VC. Measure of VC equals a measure of AV. All right, questions here? And again, you'll have a list with these formulas on the list. Kind of a lot of stuff to remember. All right, let's look at a couple of examples that have to do with segment lengths. So here's our circle. Call this X, 12, 14, and 11. All right, we have two secants. We're talking about lengths rather than angles. So we know that our rule is the whole times the outside equals whole times outside. Well, how long is this whole thing? 12 plus x. Nice. How long is this whole thing? 25? So we're just going to do this, plug this into our little acronym here. So the whole 12 plus x, need to put that in parentheses so I remember to distribute, times 12 equals the whole 25 times 11, the outside part. I'm going to distribute here. 144 plus 12x equals 25 times 11. 275. Have I showed you the trick for multiplying by 11? So to multiply 25 by 11, you separate the 2 and the 5 and add them together. Put that in the middle. That always works. So, for example, 15 times 11, you separate the 1 and the 5, add them together, 165. If it comes out to be bigger than 10, so 37, well, I'll do 38 times 11. So you separate them, 3 and the 8. Add these two together, 3 and 8 is 11, but I have to carry the 1. Or 18. It's a pretty nice little trick to remember for multiplying by 11. All right. Okay, let's finish this the other math problem. Now that we know how to multiply by 11 without our calculator. Subtract 144 from both sides. So 12x equals 275 minus 144 is 131. divided by 12, and x equals 10.9. All right, questions? Let's look at one more with a tangent segment, just so we see an example of that. When you started geometry, I bet you didn't think that there was so much stuff that we could do with circles. How did I get this little circle there? Go away. There we go. All right, so this is a tangent segment here. I'm going to call this x, this piece 9, and this piece 6. So we have a secant and a tangent. We want to find x. So we know we have the whole times the outside equals the tangent squared is our formula, our little acronym. Well, what's the whole length of this one? 9 and 6 is 15 times 6, the outside, equals x squared. 15 times 6 is 90. X squared, just get rid of that square, you take the square root. And x is the square root of 90, which is about 9.5, rounded to the 10th. All right, guess. I'm thinking of a different problem. Questions? Okay. Our homework. So just in case we need it, I have some tissues here and tissues there. This is our second to last homework assignment. Getting close to the end, so if you're getting a little teary-eyed, a little misty, we have some tissues. We do have a final review packet coming up, but this is the second to last official homework. Number 8 through 26, even. 32, 34, 35. This I'm going to collect at the end of the class. Plenty of time to do this. So